All right, let's talk about rates of reaction. What is often overlooked in chemistry is that chemical reactions have a speed to them. Just like your car traveling down the highway, chemical reactions also have a speed. Although the chemical reactions, the speed instead of being miles per hour, are molecules per minute, or atoms per minute, or atoms per second. Rates of reaction is a fancy way of saying the speed at which a chemical reaction occurs. And we measure that speed by measuring the rate at which reactant is converted to product. Rates of reaction, the speed at which a chemical reaction occurs, and it's measured as the rate at which reactant is converted to product. Okay, so if chemical reactions have a speed to them, what factors affect that speed? After all, we know we can make our cars faster or slower by increasing or decreasing the amount of gas. Can we change the rate at which a chemical reaction occurs? What factors affect the rate of a chemical reaction? Well, it turns out the same things that affect the rate of a chemical reaction are the same things that are needed for two people to meet and to fall into love. Let's take a look at a simple chemical reaction here between hydrochloric acid and water to yield the hydronium ion and the chloride ion. Well, if two people are to meet and fall in love, they have to meet, right? You can't fall in love with somebody you've never met unless you're some sort of creepy stalker person. If you think you can fall in love with somebody you've never met, then, well, all right, I won't go there. But in order for you to fall in love with somebody, you have to meet them. Same way for two chemicals. In order for two chemicals to react, they have to meet. And for chemicals to meet, they actually physically collide. They physically bump into each other. So our first factor we're going to talk about is collision. So for two molecules to react, they have to collide. So anything that increases the number of collisions increases the rate of reaction. So anything we can do to increase the number of collisions increases the rate of reaction. There are two ways we can increase the number of collisions. The first way we can increase the number of collisions is to increase the concentration. We can increase the amount of reactants. The more reactants we use, the faster the reaction will occur. We increase the amount of reactants. if we go to our dating analogy, in order for you to meet, in order for you to fall in love with somebody and meet somebody, you have to meet people, right? One of my favorite episodes of King of the Hill, and I'm tempted to find the clip and insert it here, is the one where Bobby asks Boomhauer for advice as to how to meet women, and Boomhauer takes him to the shoe store and just keeps asking women out constantly for an hour, getting rejected one after another, one after the other, one after another, until finally one of them says yes, right? Same way for chemicals. They're not going to react every time they collide with another molecule. They have to collide with that right. They have to collide in the right way with the right molecule. Their chances of having that happen increase greatly if they're undergoing more collisions. What you can think about it more concretely is your chances of meeting somebody are much better if you're out and about with a group of people on a Saturday night instead of sitting home by yourself, right? Chances of you sitting at home and waiting for that special right person to deliver a pizza to you and become the love of your life is much smaller than it is if you're out and about and attending a party with friends, or going to a concert, or going to a gaming convention, or something like that, right? The more people you meet, the more collisions you have, the faster it is you're likely to find that special someone. Same for our chemicals. So for our sample reaction, if we increased the concentration of hydrochloric acid, the rate of reaction would increase. Now, there's another factor that also affects the rate of reaction, and this factor, I think, is the bane of my existence when it comes to dating. The next factor that affects the rate of reaction is the factor known as activation energy. Activation energy is the minimum energy needed to start a chemical reaction. We're all familiar with the concept of activation energy. We know that even reactions that produce energy require some energy to get them started. Think about matches. Matches burn, they produce energy, right? We feel the heat coming off of a match when we light it. However, in order to light a match, what do we have to do? We have to strike it across something, right? What are we doing when we strike that match? We're providing energy to it, right? We're providing kinetic energy by scraping it across something. We strike a match. We strike a match in order to provide energy to our chemical reaction. In terms of dating analogies, we can think of that old Bruce Springsteen song, "You can't start a fire without a spark," right? I don't know how many times I've been on dates, and at the end of the date I've been told, "Gee, you're a nice guy. I've got a friend I'm going to introduce you to, but there's just no spark between us," right? It doesn't matter how good a match you are for somebody if there's no spark, right? Anybody else nice guy to death here? But in order for two people to fall in love, they not only have to meet, but there has to be that special spark between them, right? And that special spark in terms of chemistry is activation energy. Now, what can you do to change the activation energy? There's a couple ways we can actually affect that activation energy. First of these is temperature. Temperature has a weird definition. Temperature is actually the average kinetic energy Temperature is the average kinetic energy of a group of molecules. The higher the temperature, the faster a group of molecules is moving. The faster a group of molecules is moving, the harder the collisions are going to be. After all, if you're just walking along and you bump into somebody, no problem, you just sort of brush elbows and you keep on going, and you may or may not turn around to this person and say, "Ah, sorry, mate." But if you're not looking where you're going and you're in a hurry and you run really hard, what happens? You may knock somebody down, right? The faster something's moving, the harder the collision. And because the harder collisions are occurring, that means a greater percentage of the collisions all right, the analogy for temperature for dating is actually temperature, right? If you want to find that special someone for, well, if you want to find that special someone for at least one night, where do you go? You go to a dance club, right? If you've ever been to a dance club, you know those places are sweltering, right? I mean, lordy, lordy. Even if they've got the air conditioner going high, full bore, because everybody's dancing around and jumping, you know that you are hot and sweaty right in there, right? Your temperature is increased, and they've got the Nirvana blasting, and I'm so aging myself by referencing Nirvana. They've got the bulldog thumping and the bumping, and you're bouncing around, high temperature, meeting somebody, you're going to bump into a lot of people, and chances are, because they're hot too, you may find that special someone, right? You increase the temperature, you go someplace with an increased temperature, you're likely to meet somebody, right? Where do people go for spring break to meet people? Do they go to Canada, where it's cold? No! They go to Florida or Mexico, where it's hot, right? We know that if you increase the temperature, your chances of having a collision with the right spark increases greatly. Another way you can affect the activation energy of a chemical reaction is to use a catalyst. A catalyst is any substance that's not consumed in a reaction. In other words, the amount of catalyst you have at the beginning of a reaction is the exact same as the amount of catalyst that you have at the end of a reaction. A catalyst is any substance that's not consumed in a reaction, but serves to speed up a reaction. A catalyst is any substance not consumed in a reaction, but that speeds up a reaction. Catalysts work in one of two ways. The first way a catalyst works is the catalyst serves to lower the activation energy. You know from your own experiences in dating that in order to find that special spark, what that special spark is different on different days and different nights, right? If you've been without a boyfriend or girlfriend for a couple years, the amount of spark it takes to get you to react may be a lot lower than it would be if you just got over you've been over a relationship for a couple months or something like that, right? Beer goggles might be another example of a catalyst, right? Catalysts are anything that lowers the activation energy. In biology, catalysts are given special names. If you've ever heard somebody use the term enzyme, enzymes are biological catalysts. In other words, enzymes are chemicals that speed up the rate of reactions inside your body or inside the body of an organism. Another way catalysts work is in order for a chemical reaction to occur, the reactants have to collide with the right orientation. If we go back to our hydrochloric acid water example, the water molecule has a shape to it. It's kind of shaped like the letter V or like a boomerang. Hydrochloric acid only wants to react with water if the hydrogen on the hydrochloric acid hits the oxygen on the water. If those two parts of the molecules hit, boom, you've got a reaction. However, if water collides with hydrochloric acid in such a way that it's the chlorine hitting the oxygen, then there's no reaction between them. Because the right parts of the molecule didn't collide, right? In order for two molecules to react, the right parts of them have to collide. A lot of enzymes in particular, and a lot of catalysts, work by making sure that the correct parts of the molecule collide. And if you think I'm going there with a dating analogy on this one, you are so wrong. But biological enzymes often work by ensuring the right parts of molecules collide. So these are all ways we can speed up a chemical reaction. In summary, we can increase concentrations of reactants. We can suggest you write down Hogwarts. Hogwarts. We can increase the temperature. We can use a catalyst, and if it's in the body, we refer to that catalyst as a enzyme. That's it.